unfortunately, Peter, they have cancelled because of the disease in Rwanda. They have taken 3 students. They have taken 3 people. One is Wilbrod, another will be Sharon, and then another in agriculture. They reduced the number because of the diseases. But I looked for somebody from the faculty who is doing something I could not remember or know any. The only person I remembered was him after he presented something in Kukolobi under Indaba. Yeah, that's the only person I could remember that. I think I saw him presenting something. But the rest have not heard of anything which you are doing. Despite having these information sessions, which are good, it's okay, but we need products. We need tangible products. You can have the skills, knowledge. The first question they asked me about him was, not what are you working on? Opportunities currently, we have UNDP is having very many opportunities which they want to do research in agriculture. Have you seen what we are constructing behind? UNDP. We are constructing a factory to produce iris. But before we produce iris and add value, there is research which we need to do. The seedlings of iris up to commercialization. And they expect the IT people to be involved in that research. Yeah? To study the soil fertility, to know which soil, which seedling can grow there, to see the seedlings grow and detect the diseases which can be there and the solutions up to the marketing. And they expect our faculty to take lead. But I have not heard of anything. Tomorrow I have a meeting. Can you read only the invitation? I have a meeting, I don't know what I will tell them. Read only the heading.
Discussion on AI program development and commercialization.
That's a meeting with the Americans. We have a meeting tomorrow to discuss how they can commercialize our innovations in AI. What do I tell them? What can I tell them? Because they're going to tell me, which innovations do you have? I will tell them, we had this one who went to Japan, we had this one. But currently, unless you will update me, currently what you, because now these people, they want to discuss with KabAI, University in Uganda, on how to commercialize AI products. We have. So, we have equipment. They use mappers, they used to tell their patrons, there's a time when we invited the trainers on using drones, and they always asked me, after training, then how will you practice what you trained? So later I logged under UNDP and we got 2 drones. A drone which can go up to Lake Bunyoni. From here up to Lake. Very strong drones. It's a lot of process. Lying here. We got the virtual reality equipment. I think you've seen pictures. And the AI. Yeah. And machine learning. They are lying there. And they will just ask me why you tell us to procure these units. So we need to look for the solutions. What next do we need to do? There is a competition which is coming, the ICT competition with Huawei. I don't know if it's already out. It's already out. I saw they were conducting me, they want to come here and do some info session. So please participate. But while I've come here, I want to know the challenges you are facing to make sure you can have products. If it means I even came with the faculty budget. If it means allocating money for educational materials to give it to people, if you want Arduino boards, if you want anything, we procure them. I will do that. So, what you need to do, deal with your partner, deal with either the head of the department, any leader from you can tell the head of department that we need this equipment and this to come up with our procure. Because currently the lecturers have been asking them, can you tell me the educational materials you want to use for teaching? They don't tell me, apart from RJ45 networking and so on. Yeah. So I'm going to make sure that the money we have for educational materials, we take it to the equipments which you need. Also the equipments are not yours. I don't know if you're getting it. Yes. So if you want to produce something and you need equipment, you can pass through the department and procure and you make sure that we have a product. You get it? But currently, unless you tell me what you're working on, as a faculty, I know we don't have anything. Unless I'm not informed, I'm disconnected from the faculty. But previously, I would know, hey, there's this one who are working on smart home, there's these ones who are working on checking fake money. Hey, there's also an innovation which is using AI. There's also this innovation which is checking minimum to 100 and around 180, 100. But if you're a student and you are all yourself doing the research and you have an innovation up to 5 million. If it involves a staff member, it can go up to 100. The reason why it involves a staff member because the staff member will be accountable. You get it? A student can disappear. A student can disappear. A student can. Currently, I'm suffering with students whom we deal with projects with. They work with laptops. Up to now, getting laptops. It's a problem. Getting laptops from the students has become. But the game is it. What he's saying, if you have an innovation, you can go here with your partner, apply through them, and you can get up to 5 to support you. And they have reserved around 200 to 300 million for innovation, only innovations. And when we talk of innovations, they know focus and engineering. So this money is, and when we talk of innovations, they know focus and engineering. So this money is supposed to go to focus and engineering. But focus, are you ready to take up this money? Or engineering will take it? Already engineering last year, they took 108, I see, for the cab generator. You know that cab generator thing? Yes. They have already the money for last year. This year, there's around innovation. And we have been crying every time when I go to present the budget, I say, I don't have money for innovation. I don't have money for innovation. Then they said, okay, there is money for innovations. Are we ready to take up this money? So, I don't want to waste your time, a lot of your time. I only need to know the challenges we are facing so that we see how to look for the solutions and how to move. But what I know is there are no innovations here. But every Wednesday, you meet. Every Wednesday. So, can we be able to account what is the Costaco doing? If it is not working, we close it. What is Indaba doing? Apart from info sessions and so on, what is there? Can you show? Google developers. And most of these clubs, it is me who introduced to them. The Huawei, the Google developers, it's me who put them. If they are not working, why don't we close? So, I'm sorry if I've gone beyond your expectations. For me, it's a talk the truth. A spade is a spade. Unless you want to tell me that I'm C, like those people in the government, they say, what has he done? Ah, the man has worked. Has worked. So I want to know, what are you working on? So that when they ask me in a meeting tomorrow, which I have, even tomorrow I have another meeting in the morning with the ministry about the AI training which is coming. You've seen that flyer which was moving? Yes. I have a meeting with them to discuss on how we are going to manage it. But the other one is in the afternoon at around 4 with the Americans on how to commercialize our AI products. What do I tell them? Which products do we have? Please, I don't want to take more time. You can take over now. We look for the solution.
Okay, another reference for our professor. So you had from this communication, in case you can share your challenges now of what you think should be improved so that we reach where the expectations are. What do you think we should change? Yeah, that's what we can share right now. Or any question? Yes. His main question was, what are we working on? What are you guys working on?
So that at least I have idea.
On what you're working on, it can be an idea. Because you don't jump from zero to something. You have to begin from an idea. If you have an idea, then that is good. You can build from that idea, and then we see how you can come up with an innovation. So if you have an idea, you're on the right track. So you can start thinking in that direction. Otherwise, you've heard of the opportunities which are there, and it is now us to come up and take out those opportunities. Because now the opportunities are there, but we are not ready. And that's not good. So
Maybe as a president of 2 clubs, you can tell me what you are leading.
So, as we move on, the team has told me that they are moving around helping people to register. If you're not registered on our platform and you're having issues, you can raise up your hands and you will be helped. There's someone there. Then back on the main topic, like I said, everything begins from an idea. So if you have an idea, we should now start thinking in the direction of how do you bring that idea into reality. Because these machine learning concepts we do here, they just help you to implement. But you have to first get an idea that you can work on and try to solve a certain problem. So as we are having these sessions, please, let's keep thinking in that direction. Okay, so I want to invite our patron to have some brief communication to us before we have the main item for today. So Mr. Vincent,
thank you, sir. Good afternoon. Never had a chance to speak to the group since this semester. I'll try to be brief because we have a session about mathematics and statistics in data science. I'm seeing the floor is paid good program that I was speaking about it, because it's what I understand better. Who knows what the term endeavor means? What's that about that word? Who can tell us what it is? Come together. Pardon? basically, DABA is it's a gathering. It's a term that is inspired by the concept of Africans to gather and discuss solutions which are AI-based, that are targeting or that are solving our local problems. It's not about having info sessions. How many gets that right? Why we bring in the info sessions is because the solutions we are talking about, which are AI-based, you cannot have them if you've not done programming. So we provide these info sessions to kickstart you to build your solutions. Every year there is a continental gathering, and for people who have tried to apply for, you saw that form, right? That form, it asks for a solution that addresses a specific problem. Something that is tangible, not just going around saying, we are writing codes. No, it has to be solving a certain problem, and that certain problem must be real and should have a prototype. Prototype, it is something that you can demonstrate that's working. So now, realize that Indaba every year organizes a session, a conference that takes a week. But realize that not all Africans cannot gather in that conference. So they were like, how can we take the service to the common, to other colleagues who cannot make it either to Nigeria, either to Senegal, either to Rwanda, like this coming year. So they are like, let us start chapters. Now those chapters are what we call Indaba X. That's why we have Indaba X Uganda, Indaba X Rwanda, Kenya. It is. Now, from the Indaba X, the Indaba X Uganda, its role is to expand the services or the idea to all Ugandans. Now, the national coordinator is in Kampala. Now, they realize that having one person in Kampala coordinating the entire country becomes hard. So they are like groups. Of course, universities, primary target groups, because this is where ideas start from. If you look at these people who have studied innovations like Facebook, if you read about their history, they start from school, right? And mainly universities, not primary. So they were like, okay, now Uganda had an idea of establishing Indaba X chapters in different universities. And KabAI University was among the first universities to have Indaba X. And I think it's the most active chapter in Uganda. So that is how Indaba started. For those who have been attending without knowing what it is about and what we have to do, that is it. So the idea is not about coming here, someone comes and playing through Python, the tuples, the arrays, the what, no. You want things which are saying something about having solutions like that to solve it for problems. If I may ask, how many are in third year? Third year. If I may ask, I want to pick random. Anyone who can go and tell us their final project? Anyone? Okay, third year is going up. Now, third years, hands up. What's kind of you find out? I don't know what the starting point. Okay. It was talking about some projects which I have been with some students. There's a certain group, sometimes there's a I was trying to read through some of the proposed project management. Final project cycles were done in 2005. We are in 2024. Those are 20 years. I see someone who is in Java. You always come here. When you go to developer, you always study machine learning, and I see someone proposing without analytics or some basic system. The full system creates the function. It's best. Then I ask to get the bus, some other people are past that level of management information systems. People are now doing the things with detection, prediction, analytics, things that involve data science, that goes beyond that level of research and calculating. You do some kind of data manipulation, uncover the hidden meaning which can inform, which can propose a solution that maybe we may not have seen with our naked eyes or with basically mentally to. So I encourage you earlier, please just feel ashamed within your soul that what I'm proposing is this really work. Because the health management information you're proposing, if you go to GitHub, you can get it, right? And you put on your computer, configure a web server, and it runs. So you spend years, and you management system. The same hospital management system, the people who taught you, because by then, they were doing that, and it was the time for someone to do that, because by then we had less of technology, but now we have more. So therefore, that question, what are you working for? I think I've given a solution, right? You just tell me your primary topics. Because I guess we have to do work. So what does this mean? It means now if they are going to discuss AI and they want to commercialize, it means if your final project is worth commercializing, you can move from final project after campus, that project can earn you an MD. I think we all agree that the job market is so congested, right? Do you agree? If you don't agree, ask those who are out. Those who are going to graduate to this, the other family will get it, right? So you kickstart from there. So this idea of coming here, they do that work, hands-on work, blah blah. Please don't stop on those codes, because those codes they can't earn you. You just get the idea, then you go and do something that is it. Tangible. This coming year we have Idaba. It's going to be in Rwanda. The whole world will converge in Rwanda for the Idaba. And they are just a few kilometers, around 140 kilometers from there to Rwanda, right? That means we have more chances of being selected to go and participate. But the only way they can select you is by submitting a meaningful idea. Because that proposal, they ask you what solution, what problem are you addressing? What is the solution? And how is the solution? They ask you a video to demonstrate that. So it will be a shame if you have like 2 people going, and yet we had like a class. Actually, when I was talking with the national, it was like, if possible, if we can even have 100 students, Indaba can sponsor us with a bus. And the bus will just use a bus from here. How something to showcase. If you go there, you will never be the same people are doing. People have done things which you have not even, which you have never imagined. So, Dean has also talked about the money in the research and grants. It is very true. There is money that side. And every financial year, sometimes some money remains because people don't what? Don't utilize it. So if you're in IT, computer science, then you say you're broke. I don't understand why. Because the money is there, right? And he has told you, whenever there are exhibitions, there it's either commerce and engineering. But now at least we had some few who were trying, but this one. I think the challenge is I may not want to use this system, but let me use it. I think we are lazy. We don't want to. Have you ever given a challenge to solve? Like we don't want to butter our eggs. We just want to do obvious things. Now, if I may ask someone here, why are you doing a final year project? I want to graduate. That is the primary. You don't want to know what comes after. Give yourself a task. You wait. You have internet. You know how to utilize it. You go. Search. Actually, don't even need to search. Even around here, we have so many issues that are which can be solved by AI. Wait. You may say, for you to say, what are you doing? You go on by what I'm doing. So please, let's not leave that money. It taken by some other groups. Okay. You know, right now the world is moved by technology. And we are the custodian of what? Of technology. They recently they started a bachelor's degree in data science. Something like that. I think you can see if now such programs are coming on board, data science, we are the people who benefit from what? To be the educator in that particular area, because we have what it takes to scratch to, and we know how to click where they are told them to click. So therefore, I will not take out of time. I will stop there, but my conclusion is we have not done enough. We always come here, but I think whenever the training, the session is done, you go there, take photos, and you go back. You wait for the next week. You do the same thing. Before you realize your 3 years will be, and you do the same as I was talking to Simon to share the progress we have achieved. I also wanted to share that now we need something to give us commercialize. I think by doing that, corporates will be all that. Even if you don't do, because you get some money, that's what you're doing right now. Don't you think you can be happy with your girlfriend?
Such wonderful communication. I think you guys can now get an outfit. We can now come out of our comfort zones and start to do things. In fact, there is money and it is for us, yeah. So the choice is ours, it is in our hands. Our presentation was going on. We were joined by Madame Patricia Chamusha, who doubles as the patron for SACCO, and therefore we shall give her a chance to talk to us. And maybe those who don't know what COSACO means, ones who just hear the name COSACO, the association COSACO, you can know what it means, and you can know what its importance is. Thank you so much, Madame Patricia.
Good afternoon, everyone. I'm honored to be speaking to you this evening. And it's a blessing being in front of these ladies and gentlemen. Straight away to COSACO. COSACO brings together the whole faculty of computing, library, and information science. How many of us are members? Members of COSACO? So all of us are members. We've had some great work being done under that umbrella, and the same umbrella has Indabucks, has youth markers, has Google developers. So imagine put together. What do you think should happen there? A lot, isn't it? Lots of innovations. We've always had, there's a previous year, we had presentations, we had members we were inviting external people to come and take us through some sessions. But this time around, I don't know what is happening. I've not had a call, anyone inviting me that we have someone
Give
come.
your president.
President. What is the president? Where are the members? Where are the committee members? They are wrong. I'm honored that I'm even supervising my president. I'm looking forward for the best. So, in other words, it's not less. It's not less. We can always start from where we are, for as long as we have the energies to, the zeal to want to achieve. Now, we've already had exhibitions, and we did wonders under the umbrella of COSACO, where the faculty. How many of us attended them? Were you in your first year then? Did you attend?
Yes.
Did you love what was going on?
Yeah.
So I was expecting that through the president, we should be organizing another exhibition. But do we have what to exhibit?
We are almost getting there.
We are almost getting there.
Yeah.
Yeah, those ideas, let them not remain babies. They need to grow. You get? Let the ideas grow, and please make use of the Wednesdays to add value to those babies, right? We are here to support you. We are here to guide you in case of anything. Please give us a call. The ladies, I've liked the lady who has been standing here speaking to us and modulating the session. Please don't sit back. You know, don't sit back. This is for all of us, and I believe we can make it. Work together with your male counterparts, and you'll shine again. We shall shine again, isn't it? So, but think hard about it, because come next semester, we need something to showcase. So, Mr. President, can you please organize and show us a roadmap and tell us the plans that you have? Will you? The president has promised that after here, with his team, they will work together to give us a roadmap of what we are going to be working on, and we shall have a schedule. We must have an activity every Wednesday, right? Every Wednesday afternoon, COSAP should be doing something. It can be in the box taking lead, it can be youth mappers, it can be Google developers, but we must do something. We must do something. Thank you so much.
All right, thank you so much, Patron Safu. And we believe that as time goes by, we shall shine.
Okay.
Yeah. You guys, shall we not shine?
We shall.
Shall we not have ideas to develop? And when are we starting tomorrow? We have. Okay. Since we have them, we should develop them. Thank you so much for your good. And I think it's an opening eye, it's opening our minds. Work council, develop ideas, make something, have something to showcase, and therefore that shows us that we should come out of our comfort zones, like I told you, and have something, and continue with our, this what it is, how do they call it? Something that we've been doing. Our name should keep sounding like it has been. Now, let's have the main point of today, which was mathematics and statistics by Mr. Simon Alex Atwini, who is already here with us. I take the great opportunity to welcome him. Thank you so much. Highly welcome, Mr. Simon.
Because for me, I've gone.
Go well.
We still have an idea here.
No challenges.
We have an
no
idea.
We have an idea here.
But I request as the club leaders, you meet and discuss.
Okay.
Yeah. I've told you, if you want equipment, you can procure them. So what's the problem? The brain.
Thank you.
Good afternoon to you.
Good afternoon, sir.
So me, I'm here to provide solutions. If you don't have projects that you're working on, I can give you 1,000 of them to work on. The only thing that is going to be limiting you is your laziness. But from this talk, you'll have so many what? Solutions.
Okay.
That's the beauty with me. Me, I talk with answers. I don't talk with questions and I don't talk bubbles. So I'm going to request, if you are behind and you are part of this, please let's fill up the 16 front. Then those ones who are not part of us, can move
But
behind.
can they give me this?
I request them. I'm requesting. I'm not commanding, but I'm requesting. If you don't have part of this session, let's get it. If you're not part of us, so one, I want to thank Vincent Madiesi. He's a colleague, and of course I learned so many things from him as a person. Then I also want to thank the person who gave me the opportunity to talk to you, who is your president, Simon Peter. I hope I'm not going to be disappointing. I will deliver as expected, right? When I was learning how to compute years back, when you are learning programming, you are at the top of the world. But when you have not applied it, you don't know anything. Is that clear? So we know how to program traditionally. You have learned fundamentals. That's the reason why you can't get what? Solutions. You don't know what to do, and you can't make money. But the moment you sit down, of course now for you are still learning. The only business that you are doing here is you are studying. You wake up just to come here and do what? And study. But this world is going to put you into a corner where you have to make what? Solutions, and those solutions can give you what? Money. And you can start it now. Right? There are so many things in computing where you can get money for a living. Right now, I could say one of the most things that is trending that can feed you on an everyday basis is machine learning. It's about data science. Is that clear? Then there are also other fields that I take. Usually when we are learning, we have soft, and then we also have what? Core skills. The soft skill you should be having by now is design. If you can do anything related to design, right away from web design, even graphic design, you'll be having money every day. But if you don't want, there's going to be a time where, after studies, you will still come to be trained because you don't know anything. Is that clear? So the other thing I'm going to present here. Is that clear? Because to me, I feel I'm going to share something which is for free. And even you are getting goodies from me, so that means you have become. And let's give it that attention for 1 hour and what? Because I was talking for 2 hours. But now I'll talk for about like 1 hour and a half. We shall see how far we shall have gone. Is that clear? That's what I'm requesting from your side. So I'm going to introduce myself. I'm Simon Alex Apine, and I'm a data scientist. You cannot take away that from me. I'm a data scientist. I have masters in data science. So I speak with confidence because I know about data science. So today, if there are people around, you are free to challenge me, but I'm a data scientist. Right? Then I'm also a programmer. You cannot do data science without doing programming. You can't. It's hard, as we shall see. You can also not become a data scientist if you don't know math. That's the reason why I'm here. I'll explain. Don't be scared about math, because I'm going to explain what you need to be known. Then you can start your journey as early as possible. Is that clear? So I'm Simon Alex. So that's basically the introduction. I have masters in computer science, I have bachelors in computer science. Then I specialized in what? In data science. That's what I specialized in. What I worked on, I had people saying, you are looking for solutions. You are only going to be implementing. And to me, I don't want people who implement. I want people who add value to the existing knowledge. Is that clear? Let's implement, but add knowledge to what is there. But the challenge is, for you to add the knowledge, you must know how to implement. Is that clear? So what I did as my final thesis, usually people call it dissertation, but mine I called it thesis, and I had to stick by it. Because they say thesis is for PhD, but mine was thesis. It wasn't a dissertation. I tried to do denoising using autoencoders from images which have already been what? Contaminated. That's what I worked on. That's clear? So it wasn't getting AI and applying it to medicine. Getting AI and applying it to agriculture. I was adding to knowledge what is existing. Can I extend the algorithm and remove noise using autoencoders? That's what I want. My name is Simon Alex Atwine. You can search about me. There is plenty of information that you're going to read about me. And I've also published some work, some papers, collaborated with others. So I started my first work at the university. I was volunteering in AI lab. Now when I'm given a chance to talk about data science, I will talk for the whole day. Right? Because I started, that's the first thing I worked on. So this is now the opportunity I have, the first opportunity in KabAI. So let's get started. Eh? So enough of the introduction. So today, I'm going to help you to understand data science. Then from data science, we shall understand. Because usually people confuse with machine learning, artificial intelligence, deep learning. For you, you think all those terminologies mean what? Data science. But data science is a container where those ones are what? So the moment you tell someone that you're doing machine learning is different from what? Deep learning, as we shall see. That's clear. And everything comes from what? Artificial intelligence. So after we have understood that, I will take you through the machine learning toolbox. People who are here and they are developers, you have a toolbox. You know about some programming languages, right? Maybe you know Python, maybe you know PHP, or you just know about scripting languages. Is that clear? JavaScript and the rest. So that means you have a toolbox. So whenever you are going to work, you have to make sure that your machine is ready for those what? Tools. The same applies to machine learning. There are tools to learning. The challenge is you want to apply machine learning and you even don't know your what? The tools. So that means your toolbox is already empty. But you want to do what? To apply. So I will take you through the machine learning toolbox. And that's where we are going to find what? Mathematics and statistics. Because it is among the tools that you need to be knowing as a what? A data scientist. So all of us are aspiring to become data scientists. But effort. You have to work to go for what? To go for data science. So what is data science? The terminology I've talked about, one, two, we have machine learning. And three, we have what? Deep learning. And you see from that Venn diagram. Most of the times when you are confused about something, of course it means those technologies are what? Related. That's the reason why you are seeing data science probably being involved in every what? Part. Is that clear? So we are going to go step by step. That at the end of the day, we shall understand what is artificial intelligence, what is machine learning, and what is what? Deep learning. I hope we are clear here. Now, if there are people who are doing statistics, data science is not data statistics. Those two are different. When you are a data statistician, you only estimate. But when you become a data science, you measure. So even when you are presenting, they are interested in seeing how your model is performing, but they are not interested in your forecast. Is that clear? So that's it. You measure about those two terms. Data statistics, we are estimating. But when we come to data science, we are doing what? We are measuring. If you have questions, you will stop me by and ask. So now artificial intelligence. The easiest way to understand artificial intelligence. These computers are primarily designed to do what? Process data. That's what they are primarily used for. But this approach that they use has evolved over what? Generations. This is what we study in computing. That in computers were using what? Talking tubes. Second generation computers were using what? Transistors. Third generation computers were using what? Integrated circuits. Third generation, which is the third generation, computers are using what? A central processing unit. What is anticipated, but no longer anticipated, is that computers were to start using what? Human beings. That's the generation we are in. It started as early as people, and it will have auto-suggestions, meaning that you're using the concept of what? Of artificial intelligence. Is that clear? So I mean that generation is no longer far-fetched. It's the generation we are living. And to make matters right now, we are doing bits 0 and 1. And there's also going to be quantum computing, where computers are going to be extremely fast. And I think these technologies are designed in such a way that they can simplify our work in what? In data science. Because what is limiting us nowadays, you can train a model for almost like a week. So if the computers are extremely fast, it means we shall be in position to train a model in the shortest amount of what? Of time. Is that clear? So you get time and read about quantum computing. It's really interesting where technology is going. And I'm one of the people who sit down. I'm interested in latest trends, where computing is heading, not where it came from. Because where it came from, that's traditional, it's theory. And we all aspire to move with technology where it is what? It is taking us. Is that clear? So that's it. So artificial intelligence is as easy as that. That's the fifth generation of what? Of computing. Which was anticipated, but we no longer anticipate for that. Because we are already into what? Into artificial intelligence era. Now, what is artificial intelligence? Who can answer me that very fast? What is artificial intelligence? Yes, please.
Artificial intelligence is the ability of the computer to make human thought.
That's it. Eh? So in short, when we are interacting with artificial intelligence, we are giving it the ability to think. Computers, we are giving them the ability to do what? To think. So they are simulating what? Human beings. But we are only simulating human beings on what? When they are thinking completely. Is that clear? That's where we are stopping. So we can move on. So that's clear that now we understand what? Artificial intelligence. Let's move forward. Now this pointer here. I'm going to need to leave it. So now let's understand the term machine learning, because this is our what? Our roadmap. I want us to first understand what data science is. So already we have understood what artificial intelligence is. The next thing, I'll take you through machine learning, and then we shall end with what? Deep learning. Then we shall try to see, is deep learning different from machine learning? So let's move on. Now, to understand machine learning, like I said, you need to be a programmer. A program, usually you define it as a series of what? Instructions that a computer follows to perform a what? A given task. That's clear. So when you are implementing, what are your inputs? The inputs will be data, because you have a number of what? Data structures. So if I'm speaking to people who have done Python, meaning you work with lists, tuples, dictionaries, variables, those who are advanced, even store their data into what? Databases. Is that clear? So that means as we program, the inputs are 2, it's not 1. You're not giving the computer only series of instructions or rules, but you're also giving it what? Data. Is that clear? Then the program is supposed to return a what? An output. That's exactly what happens in what? Traditional programming. You open up a text editor, you write your series of instructions. Those series of instructions, you can decide to even input files, or if you want, the primitive ones, you can input what? Values into variables. That's clear. But then when we cross to machine learning, the concept changes. Machine learning, because it's built on programming. Now when you go to machine learning, we input data with even the output. Then machine learning gives us the what? The rule. That's exactly what with programming, we are giving the computer data actions. Then it will give us the what? The output. But when we cross to machine learning, we are giving the computer data, and then you also give it the output. Then you let it write the what? The rules. That's the easiest thing. That's the reason why when we are defining machine learning, we usually say it is simply a field of intelligence that enables computers data without explicitly being programmed, because there is no programming there. I know some of you are going to have numerous questions. If there is no programming, why do I need programming? Is that clear? I will answer that as time goes on. Because the reason why you need programming, remember for you now, you're not implementing, but you are designing. Is that clear? So what you are designing is, you are designing machine learning. So you must use a what? A language to achieve that. I hope that's clear. If you have questions there, no questions, we shall proceed. Now, applications of machine learning, that we can appreciate it. Of course, we all know. Yes, please.
You are spoke of something of machine learning, where we give that as an input, and then output, and then gives us some rules. What are some of those rules?
Rules.
Yeah.
Rules are a series of instructions. Yes, a series of instructions. They are the rules. How many of us know CSS? How many of us have worked with CSS? Cascading style sheets. What do you write? Usually CSS, we call them rules. That's just terminology. Is that clear? So a series of instructions are the ones that I'm turning to be what? Rules. I hope that's clear. Okay, we can move on. Now, of course, we must appreciate machine learning. It has helped us in a what? In a number of what? Activities. We have heard about self-driving cars. Is that clear? We have also heard about recommendation engines. These are very many. Starting from Netflix, you go to even YouTube. The moment you start watching videos, even TikTok does that. It is just going to customize whatever you are using, the system that you're using, to give you what? Things that you like. Is that clear? So if you are someone who reads about Python every day, you're going to find that every time you open your YouTube channel, you have a playlist of what? Of programming and Python basics. Is that clear? So usually if you want to assess yourself, how serious you are, open your YouTube channel. You're going to see what you watch. So you want to come up with solutions in programming, but you find there is plenty of music, meaning that you can't program. Because all your life you are given into what? To music. So usually what you watch is what you get from what? On YouTube, what you like in short. Because that's what you search. So it uses those search words to come up with a what? A recommendation system. That can be vague. I told you I was going to give you solutions. Think about a recommendation system. that you can work on. Look at others. See what new things you are bringing in your recommendation system. So as easy as that, you have a final year project, which you are proud of. The next thing is spam filtering. Now, because viruses are born every day, there has to be what? Mechanisms for making sure that this spam filtering is good enough not to send you what? An affected file. Is that clear? So you must appreciate the works of Google, and maybe there are some people who are still using what? Yahoo. Because those guys do a lot of stuff. Now, their job is simplified. When machine learning came on board, their work was simplified. They no longer now need to write rules to stop what? Viruses. Because machines can learn messages. If you send a message without a what? Without a subject, it is flagged and put to the spam. If you are someone who receives those messages without subjects, then they will be brought out of the what? Of the spam. So any unusual activity that happens is the what? That this one here, simply do what? Spamming. Then we also see it in face recognition. People who are interested in computer vision. That's why we use what? Facial recognition. Right now, some of the devices they implement, they even give you an option. If you don't want to use the password, you can use what? Your facial recognition. So, and of course, others, there are so many. Is that clear? So, me, I'm just shading this to show you where machine learning is being what? Used. There are so many what? Areas where we are applying what? Machine learning. So, let's move on. Now, these are some of the machine learning buzzwords that I feel I should break out. Then we can move on. One, what is an algorithm? This algorithm shouldn't be confused with the algorithm of what? Of programming. Because with algorithm of programming, we are looking at well-defined following. But now machine learning, we are now going to be looking at what? At statistics. Is that clear? So usually I say these are rules, but they are statistics based. And once you follow them, you will get a what? A model. Is that clear? So statistics, that's already there. You're not going to come up with a new algorithm. Because we have a number of what? Statistical algorithms. Linear regression, logistic, there are so many. There are so many. So here, those are the what? Those are the rules we are looking at. Then the next thing is a model. Now, a model is usually the output of your what? Of your algorithm. So usually I tend to call this the algorithm. A model is simply going to be relying on the algorithm. That's clear. So the logic of a model is the algorithm. Because the model is supposed to be doing what the algorithm does. So it's as simple as that. So the main component of machine learning is the model. Usually when you are coming up with machine learning, they will ask you. They will not ask you your output. They will say, what is your model doing? Because what is your output doing? Because what you remember to train is the model. And the logic of that model is going to be a what? An algorithm. Where the algorithm is statistical. Those statistical algorithms have spent years existing, logistic, linear, they're not new. But for you to are picking one that you feel will work based on the data that you have, to come up with a what? With a model. We move on to another buzzword, which is training data and testing data. Training data is the data which you use when you're training your what? Your model. Then the data that you will use for purposes of evaluation is what we call the what? The testing data. So that means if I have a data set, you first split it into what? Into two parts. You have a training data and then you also have what? Testing data. Then you use now training data for training. But you hide your what? Testing data. Because that's the data you're going to use to evaluate your what? Your model. So you don't use them for purposes of training. So we can move. If you have questions, you stop me by. Now, this is our machine learning process, meaning that right now, we aspire learning engineer. So where did we start from? So now I'm computing the brain than what I expected. So the first thing that you are supposed to do is define an objective. What is it you want to do? That's the first thing you think about. Then the next is now gathering data. The beauty with machine learning, we no longer do data collection. There are a number of data sets on table that you can use. Anything that you can think of, there is an available data set. If you are thinking about, let's say maybe you are doing something related to cassava, there is a lot of data for what? For cassava. If you find there is something that is lacking, then that means that is an opportunity for you to make money. That you can collect data and make money. Because people will buy that data. As long as the data you are collecting is missing. For example, I can use about banana wilt disease, if you have heard about it. So if you can collect plenty amounts of data for that, you will be a millionaire because that data set is not there. So it's just a new disease in what? In banana. Meaning you can collect data. By data I mean a numerous number of what? Of images. You're not going to come up with 1,000. You're not doing now. You need to have data. That's clear. You can report that movement. So that's data gathering. Now that means after collecting data, if the data is not enough, what do? There are techniques we use in machine learning. I don't want to make things complicated, but we have plenty of techniques we can use there. One of them is data augmentation. That if you took one photo, that photo is going to be, and the beauty with machine learning, when it is marking you can train a model which is going to be working 90%. 90% of accuracy. That's it. But when you put it to the real world, the model will give you even 10 or 0%. Why? We have two components in machine learning. Two aspects you need to understand before even you start building a model. Overfitting and underfitting. Some of you are here, you have spent 3 years, 2 years. Is that clear? You are going to cram books, you will get first class. But the world doesn't need your first class. It needs your skill. What skill did you go with? So when you go to the real world, they will say, install an operating system. You don't know, but you know what an operating system is. That's the same thing with machine learning. If you are going to give it data and you spoon feed it, it's going to overlearn the data. That's what we call overfitting. Then when you give it new data that it has never seen it will just do what? It will grow. Is that clear? It runs into a deadlock. Because you have to overspin it. That's clear? So, if you are here and you're doing computer science, don't aim for first class. That's the tip I'm going to give you. Aim for first class that you are going to defend. Because that first class is going to give you your first job. And you are going to learn into a deadlock. People are going to mark you that you don't know anything. So let's be wise enough. If you have a first class, it's normal nowadays because there are even academies that are starting up. That after you graduate, you're not ready for work. So you go to what? Skill enhancement and development. That's the reason why even when you have PhDs, they will say, do you have certificates, certifications? Because they believe, much as you did networking, you're not ready to do what? To network. Is that clear? That's the world we are living in. We can move on. Now, after preparing your data, the next thing is data exploration. This is now where you grab your detective lenses or glasses. And then you look deep at the data set. What are you looking at? You are looking at that data to see if they are what? If they are insights or patterns that you feel you need to run. So if it was, let's say, rain data, you are interested in looking at that data set. What do you think is in that data set? Is that clear? The new thing that you will find in your data set will also influence your what? Your model. So, we are going to see that usually when we are doing machine learning, we do something called future extraction. Is that clear? So when we are doing that, data exploration, we are busy looking at future extraction. What is going to be my independent variable? What will be my what? Dependent variable. You shall see that. Lastly, not lastly, we build a model. Is that clear? This model, we build it using machine learning algorithms. The statistical algorithms are taught that have existed for years. That's why you pick an algorithm, you simply apply it. So there is nothing like machine learning to write the what? To write the statistical algorithm because they are already there. You only need to pick and apply. The next thing is now model evaluation. The other data set, we will say, is supposed to be split into two parts. Training data and also what? Testing data. So when you come to model evaluation, you are getting the other data sets that you had to do what? To hide away, which we call what? Testing. Then you use it to evaluate your model. How is it performing? That's when you get the accuracy about your what? Your model. Usually what we use here is that if you are doing regression, we have something called a confusion matrix. That you can even present, if you are presenting to a model, you present that this is a boy. The model will tell you the boy is pregnant, which is not true. Is that clear? So when you're also training your model, these models usually they are confused. There is where they are performing well and there is where they are performing what? Poorly. So that means that's when you go to the confusion matrix and look at how your model is what? Is progressing. Then finally, you will deploy your model and then start what? Predictions. If you have a question, yes. And once you master that, you have mastered data science. Even if you want to extend knowledge on that, you can pick an area and say, me, I'm going to extend knowledge on model evaluation. That's clear? Or I'm going to extend the knowledge on building a model. So this is now where you have to think. Then if you are now looking for solutions, they are saying, go and find what? Projects. It's easy. Look at this and see what did you want to do. Is that clear? Then you look at this. Can it fit in? Then if it fits in, you start working. And the beauty with this final year project is that you don't need to look at, usually the challenge is here. For you want by the time you are starting, you have a solution. That's the truth. People want to know if I'm going to work on an academic management system. I have already the what? The solution. Then you are only concentrating on the portrait. Or you even have the order and the what? And the delivery. That's the reason why these final projects are always going to be a problem. Think about a problem, work on the problem. And the beauty with it, you don't need to finish your problem. But as long as you can have something to simulate that I was working and I'm out of 10, I've reached here, that will be good enough. Is that clear? Artificial intelligence came long time ago, 1950s. But it is gold cake now. And the person just left work, which we are building on to come with what? Models. He only looked at artificial intelligence, he looked at even machine learning. So if you're working on a project and you're sure you're working on the project, trust me, you will still graduate. Because you will still come up with a delivery and present. And even show people the future what? Prospects. Is that clear? So don't work on something and feel like this I have to die with it, think when it's complete. Even what you are thinking is complete is your mind. Your mind is just shooting through completion. So people will even challenge you that you have not even what? Completed. There is so much that you have to do. So usually, me I advise people, there are so many things you can work on. And if you are still stuck that you can't find a project, how many of us know Google Scholar? Go to Google Scholar, search about something that you want to do. Look at future work. And do the future work of other guys. You will like there your what? Final year project. However, I don't usually recommend going to future work. Why? Because when you are lazy, and then you go to future work, you're going to die. Because future work means I work, and then I could not think anymore. I stopped there, but I wrote it as future work. Is that clear? So it will be hard to break out of the what? Of the future work. But that is also another advice for people who are looking for what? Projects. You can think about that and go to the future work. If you are interested, because you will have what? Problems there. Problems there are many. If you don't have a problem, go there. There are going to be plenty of problems. This is the training and this is the testing data. There is no magic on determining training and testing. When you are doing data cleaning, of course there are some things I've skipped, right? When you're doing data preparation, usually the data set you will have is going to be having inconsistencies. These inconsistencies could be what? Missing data values. So you're supposed to impute them to make sure you don't have what? Missing data values. The data set you will have is going to have categorical and numerical data. You can see there. You will have numbers and data which is not in numbers, it's in words. Is that clear? But the model only takes on what? Mathematical based, meaning it only takes on numbers in short. So you have to think about how do I convert words to numbers. Usually we use one model coding to do that. You just simply get the words as long as you categorize them. This is Spain, this is Uganda, and then it will give you 1 and 0. Where 1 is maybe standing for Uganda, 0 is standing for what? For something else. Is that clear? So how? You don't need to worry about testing and training because you have a data set. So what you do, you get your data set. We are even privileged that there are even things what to use. You can just split these functions you're working with in programming. You get your data set, randomly split it. That's clear because you don't want to bias things. So you randomly split it into testing and what? Training. We usually recommend using 60% of your data for training. Then the rest you can use it for what? For testing. But that one even, people have moved the mind of saying 60% is not enough. So we use the standard now. We use 80% to train, 20% to what? Test. Those are the questions we ask. If you are a data scientist and you are looking for a job, someone will smoke you up. What percentage do you give to training? What do you give to what? Testing. 80-20, because that's the standard. So we can move on. If there is any other question, you can ask. Okay, we can move. Now, we got machine learning types. These machine learning types, think about yourself when you were young. You didn't know anything. Is that clear? That means you started to learn using different kinds of approaches. Some people were guided on how to walk. So the same applies to these computers. There are approaches we can use to train them. The approach we use are 3. 1, supervised learning. So with supervised learning, this is where you are now giving the what? The machine labels, data and labels. If I have images and I want you to categorize, I will simply name my images. This is Tom, this is Joshua, this is Peter. Is that clear? Then you train the machine using images with their labels, with the target that the machine should be in position to even predict on its own without a what? A label. Is that clear? That's what we call supervised learning. Meaning, the machine is learning with someone even helping it. Usually we say, the machine is learning, but with the help of the supervisor. You are working, but the supervisor will keep coming. Have you printed? Have you done this? That means that's supervised learning. He's following you up. Then when we cross to unsupervised learning, this is now where if I want the computer to categorize the images, I don't even tell it about the what? The images I've given it. But the goal is to what? To make predictions if I give it another image. Meaning your data is what? Unlabeled. So that means the computer will now do what? Cluster. It first clusters. And then it goes to the k-nearest, something like that. I want to go in deep into that. Not to confuse you. Now, before we go to reinforcement learning, there is also another new approach. Most of the times when we are collecting data, this data is partially labeled. Is that clear? That means you have more of the data images or more of the data items being what? Unlabeled. Is that clear? So you find you have a data set, but this data set has got labeled data and then unlabeled data. So we have an approach that we can use there called semi-supervised. Is that clear? Semi-supervised. Meaning you have plenty, let's say if we are using images, we have plenty of images that are unlabeled. And we have few or partial images that are what? Labeled. So there you can think about semi-supervised what? Learning. So if you are looking for a project read about supervised learning and see what you can do. Because for you at your level, you are implementing, you are not even extending what? Extending what is existing. Just create a problem where you can put there what? Supervised learning. That can be your final year project. We move on to reinforcement learning. Reinforcement learning is now an approach that is being used to implement these what? Self-driving cars that you have heard about. So with reinforcement learning, you simply get an agent. Assuming, let's say, you are going for a mission and you're a soldier. You are just dropped into an environment. You don't know what they eat. You don't even know about their behaviors. But you have to figure it out. Is that clear? That's what we call reinforcement learning. So you simply bombard the machine with data. You let it figure it out. You don't give it anything. That's the self-driving cars you hear of. You get a you get a car, you just put it on the road, you try to see. If it knocks an object, you penalize it. It knows that is bad. It's not supposed to knock. Is that clear? That's how they what? They learn. It's very easy, by the way. Doing data science. You understand? It is fun to learn. So the reinforcement learning, that's it. There is no logic there. You are only going to be learning by what? Penalties, and usually call them rewards. Rewards, but these rewards are what? It's either going to be a penalty, it's a fine, or I'm just going to be what? Rewarding you. So it is similar. Now, for people who want to learn, if you are having issues with studying, start penalizing yourself and you'll see. When you don't read, usually we have timetables that we create, but we hardly follow those timetables. Now penalize yourself that the day I'm going to follow my timetable, I'm going to eat lunch. Can start with lunch and supper. So you have a strong one of them. That if you don't follow your timetable, you don't take maybe supper. If you follow it perfectly, you take lunch and supper, you will see. But now you're not training yourself. It's the mind. Is that clear? We all have a brain. That's what you're trying to penalize. If you are laughing, people who actually are performing better in class, look at their habits. They are different from you. This person trained the mind to say, if I go home without B, there is a problem. Even when they are not going to ask him, he trained the mind that he has to do what? Perform. That's it. That's simple logic. So if you are in class, no one is dull, but it is how you train your what? Your mind. If you train your mind to say, no, I have to get A in this, you will get A from it. Because you'll have what? Penalties. You're going to say, when others are going for football, for you feel there are more chapters to cover. So you won't go. Because the mind is programmed to make sure that it can do what? It can work on that. It can proceed. As we go by, you're going to see that, by the way, this one here is guiding us on how we can train our mind. Because we are not even knowing that. Is that clear? We are training the machines, but we even have purpose that we can train ourselves. Let's move on. So that's it. If there is a question there, you can ask. These are approaches that you can use to train your what? Your models. Now, so here I'm going to rush because I've already explained each and everything there. Do we see Tom, Jerry? This is now supervised learning. You are giving model the data which is already what? Then let's take that as a black box. But usually that I'm calling a black box. That you are seeing as training phase. Most of the things I've talked about there during the machine learning what? Process. Is that clear? Then the output. The machine now, the output that you are seeing there, that means now you are challenging it. You bring Jerry and Tom, and the computer will be able to identify. Say, this is Tom, this is Jerry. That's the same way we learn from our childhood. You are given a Latin alphabet with A up to Z. You have numbers 0 to 9. Then you are trained. This is 0, this is 1. Is that clear? Then after you identify, you start to rate. There's no magic there. So the same. That's the machine. That's what? How machines work. We move on to unsupervised, which I explained. We also have Tom and Jerry. But right now, if you look at our inputs, they are not labeled. When we give it to the machine, it categorizes to say these are similar images, puts them into a cluster. These ones also are similar, these are also in another what? Cluster. That's exactly the same thing you're seeing there. Meaning the computer has finished identifying who is Tom and who is what? Jerry. That's an unsupervised. Because data is what? Unlabeled. So reinforcement learning, of course I don't have an image for that because here we are just going to get the machine to figure it out by giving it rewards and what? Penalties. Now, types of problems. Machine learning, artificial intelligence, by the way, doesn't do everything as you think. There are some things that are not machine learning based or artificial intelligence based. Is that clear? So we also have types of problems. Types of problems where you can apply what? Machine learning. So these types of problems are, there should be classification, regression, and clustering. So whatever you are thinking about, if it requires regression, go for machine learning. If it requires for classification, you can also apply what? Machine learning. Or if it requires doing what? Clustering. Do we have questions there? All right, so if there are no questions, I will proceed. So these are the types of problems where we apply what? Machine learning. I'll not let classification is regression and clustering. Is that clear? You can figure out that. Regression is a continuous value, as simple as that. If you're going to be predicting continuous values, for example, the speed of the car, something like that, continuous. If you are looking at now regression, that means there it can be logistic and it can also be linear. But we are limited by classes. So it's now not continuous. You already know the answers. But those answers can be multiple or it can just be what? It can be just when you're looking at recommendation systems because they are clustered in your content. So we can move on. If you're interested, you read further about what was needed. Yes, please.
How about for reinforcement learning? How do I identify the problem, the challenge I'm solving follows under
Reinforcement learning. How you identify that the challenge falls under reinforcement learning, like we have said. You do not know how to get to what? To the solution. So you just give the machine and you let it figure it out. Is that clear? So usually if you have a challenge, where the challenge you are not sure if it is classification, regression, or clustering, try reinforcement learning. That's what the cars are doing. Is that clear? A car, you are not sure if it is going to do clustering, you're not sure if it will do regression, classification. So you just dig it on rows. And then you arrange your obstacles. Then you try to see how it works. The same way how these dogs work. How many of us train dogs here? Dogs use reinforcement learning. You make sure that if you are to send it for something, just give it a token to eat. That's clear. Eventually, it will perfect. We can move on. Let's move on. Next, now we are going to understand. So we have understood machine learning, we have seen what it is. Giving computers the ability to plan on their own without being explicitly what? Programs. That's what we saw as machine learning. Now, what is deep learning? Of course, deep learning is simply a part of machine learning, but it is different. We can distinguish machine learning from deep learning. When we are studying, we had our first course unit called machine learning. Then later we had deep learning. So people are saying, now we are going to do machine learning, we are going to learn deep learning. Because they are closely related. And for you to understand deep learning, you must have done what? Machine learning. But it's very easy to distinguish. When you manually extract your features, you are doing machine learning. Assuming, let's say, we wanted to identify who is, let's say Simon. We are going to look at features. Facial, yes, we are clear. So, what are some of the facial factors or features that we can use to identify a person? If the person closed eyes, would you identify that person? Yes or no? Because that's it. If the person had to wear a mask, would you identify that person? So that's where you get your features from. Now once you get 38 features about your data that you can use, you have done what? Feature extraction. The same applies to data sets that you learn into. If you are going to get a data set, let's say that data set is about rain, then you want to predict about a possibility of going to rain or not raining. The data set is going to be having a lot of what? Data items. Then those data items that you feel can influence what you get at the end of the day are the ones you refer to as what? Futures. Is that clear? So, machine learning, you manually mark your futures to say, I'm going to use the nose, eyes, and the rest. Is that clear? But when you go to deep learning, you don't need to do anything. You only fine-tune the parameters of the what? Of the model, but you don't select what? Futures. Then you will get what? Results. Now, of course, if you are lazy, like they have said that you are lazy, if you are lazy, don't do machine learning, do deep learning. It's easy. Because then you don't need to think about what? Futures. You only need to think about parameters. You even specify 80% use it for what? Training. Those are the parameters you are feeding when you are doing what? Deep learning. So deep learning is easier than machine learning. But for you now, when you are doing deep learning, you must come here and defend your work. So people will ask you, which features did you look at? You want to know, because everything was left to the what? The machine. That's the hard thing about deep learning. But deep learning and machine learning we are doing what? Manual, future extraction, then deep learning, it's just automated. So if you have a question here, you can ask. So we can see here, if you want to identify a bicycle, what you are seeing there on future extraction, those are some of the parts you can do as. You can future extract. Like if you see this, that's a bicycle. If you see also this, that's a bicycle. That's clear? Yes. Then now you let the machine learn using those features. But if we go to deep learning, that means the story also what? Changes here. This component is not there. This component of feature extraction, if you go to deep learning, you don't see it there. Is that clear? It takes the entire bike and then it will make what? Predictions. If there is a question there, you can ask. That was it about the difference between machine learning and deep learning. I hope that's clear. One, you are doing feature extraction, the other is automated. So, yes, please.
So it means with deep learning, we just have to fetch an algorithm that does a classification by itself.
Yes, that's it, idea. So when you're doing deep learning, what he's asking? He's just asking, do you need to know how to classify or what? Of course, using your parameters, you specify in parameters what your output, what kind of output you want. That's it. But the rest, classification, this one, you don't need to care about it. Just understand your data set and look at parameters that you're supposed to do what? To fine tune, and then you'll have your what? You'll have a model. So we move on. So now we go to the machine learning toolbox. Since now we have understood machine learning, deep learning, and artificial intelligence, what do we need to learn? That's a toolbox. Meaning, these are things you must have on your fingerprints. One of them is data. You need to have a data set. I'm calling it a gold mine. Because without data, you can't do anything. Data science heavily depends on data. Without data, that means it is incapacitated. There is nothing you can do there. Then now, how do you get that data? We shall see that shortly. Where do you get data from? Then after you have identified the data set to use, the next thing is the infrastructure. These are now platforms and tools. What platform am I going to use? I'll also take you through that. Platforms and the tools you can use. Then lastly, we have algorithms. So algorithms, I've already explained that these ones have been existing. They are statistical algorithms. So you also need to know them, how they work. You just read about it, and then you apply. You don't need to take a lot of time, but you just read about that what? That statistical technique, read through it and see how it works. Then you can try to get it and do what? And use. We can move on. So this is what you need. You need data, you need an infrastructure, you need also what? Algorithms. Now data. Data which we work with is usually structured. It's either structured data or non-structured that I'm calling what? Unstructured. If you are beginning, when you're a beginner, you're a beginner by the way. Don't skip steps. That's clear. That's the reason why if you have taken time to read some articles, someone will start by calling you a fork. And you feel okay on doing what? Offended. Is that clear? But it is right, because you don't know. That's the reason why you're reading this article. Is that clear? So, if you are a beginner, don't jump to non-structured data. Start with the structured data. This structured data is simply data which is what? Which is organized in two tables. Tables usually have rows and columns. There is no magic. Is that clear? So start with that kind of data before you can advance to textual or that data which is in form of what? Of images. Is that clear? So we can start from there. Meaning, start by doing cheaper things, right? I want to predict the price of a house. Those cheaper things. Because their data is usually in tabular format. Before you can go to say, I want to identify Tom and Jerry. Tom and Jerry is complicated because it's using what? Images. Then from there, you advance like that. Now, where do we get data? The machine learning repository for data is called KabAI. And I've written it there. So you can go to KabAI and look at different kinds of data sets that are there. There are very many data sets there. Even when there are other repositories, the other repositories are also getting data from what? From KabAI. It is similar to just designing up a web page and pointing people to what? To KabAI. So they simply point. They are pointers. But all the data comes from what? From KabAI. Do we have questions there? So as you plan to become a data scientist, at least there are some of the main terms that you don't skip. Structured and unstructured. Even if you are doing data statistics, you learn about that. Because you have to know what kind of data you have. Is it structured or unstructured? And it is simple. Any data which is organized, and also the time is in tabular format, is what we call structured. Then the one which is not in form of text and images is what we call what? Unstructured. So we can continue. If you have questions, you will stop me by. So we are done with this first part of our what? Of our toolbox. But moving on, we need to understand where does this math come in? The statistics that we are talking about. This is a table. We all agree. Is that clear? It has rows, it has columns. But when we cross to machine learning, it's no longer a table as we think. There are so more other what? Attributes we can add to this table. One of them, those rows we usually call them cases or observations. You have observed on an everyday basis. Is that clear? Meaning you have plenty of cases and plenty of what? Of observations. When you cross now and look at fields, those fields are no longer columns as you think, but they are vectors. Is that clear? I will explain this in that it makes sense at the end of the day. So those vectors, if it is more than one vector, it becomes the matrix. And it's simple math that you don't need to spend ages trying to figure out what is a vector, what is a matrix. As long as you have more than one vector, you have a matrix. And when you have data which is tabular, and that's what you call a column, usually you call it a what? A vector. Now, to our understanding, if I was predicting prices, that means I'm going to have X and Y. Is that clear? The X and Y are variables. Meaning those variables, I need the independent variables that we call X, and the Y, which we call what? Response variables, or dependent what? Variables. So, if this was our data set, we shall need to identify what is our X. Is that clear? And what will be our Y. Usually we identify the X because already you are certain or you're sure of what? Y. So that means what you identify as X. If it is more than one, you have a matrix. If it is just one, you have a what? A vector. I hope that's clear. So we can move on. If you have questions, you can ask. Because this is common. Some people ask, what is the independent variable? We don't know. What's the dependent? We don't know. It's common. But if you understand this logic, it's very easy to identify your independent variables and also your what? Dependent variables. We can continue. Now, moving on, this is what I was explaining about X and Y. So you can see That means at the end of the day, if we have multiple vectors, like we have a matrix there, those will be our what? Our x. And then our y will be what? Price. Meaning what we are predicting is y. And it is being influenced by independent variables, which we are calling what? X. And then the beauty with all this is, if you are going to be doing with machine learning, you already have functions that you can use to split your data. It is just a matter of specifying, I need this to be x, I need this to be y. And that's done. So we can proceed. If you have questions, you can ask. So the independent variables, we can call them predictors sometimes. Then the dependent variables, we call them what? Response variables. Those are just terms. So we have a number of terms that we can use interchangeably. So that's done now on data. We go to the infrastructure. What do we need on the infrastructure? You need to have a computer. That one I've not put it there. So on that computer, what should be there? If you are someone who has the work offline, download an Aponda. But I usually prefer to go the Google Colab. Because when you go to the Google Colab, everything has been pre-installed for you. Everything is there. But that is online. You need to make sure that you have what? Data. But if you don't have, you can download and install what? An Aponda. Of course, an Aponda simplifies things because it is an integrated government what? Environment. You will find there Jupyter, Spider, all those will be installed for you. But if you are someone who is interested in looking at even individual components you are supposed to install, then you can go for Jupyter Notebook and install it, or you can go for what? Spider. But if you want Spider and then the Jupyter Notebook to come with some libraries pre-installed, I prefer you go for what? An Aponda. So that's the platform you need. Now languages. Of course, there are a number of languages that you can look at. Is that clear? Languages which you can look at, we have Python, we have C, we have C++, there is R, we have MATLAB, and then you also have what? Octave. I will start from the bottom one, which is what? Octave. MATLAB is commercialized. So you are not going to raise money for that. Is that clear? So you can go for Octave, because it's the community what? Version that you can use freely. So there's no magic there. So if you are an engineer, if we have engineers here, civil, I think electrical. Those are guys who work with MATLAB. Because for them it is required, since they are doing what? They are doing programming which requires linear equations. So those linear equations are easy to work with in MATLAB and Octave. Then we have R, C, and then C++. Now, if you go for R, it limits you. R is only used in what? Data science. But you cannot implement a standalone application using R. You cannot come up with, let's say, a web application we are using what? R. So it is more specific, tailored for what? For data science. That's where it stops. Then we also have C and C++. These are languages that have been there for what? For years. Even the languages that you are seeing, like Python, they are simply developed out of C. Is that clear? So meaning you can say the mother language is C. These other languages are developed on top of what? Of C. So I usually say C and C++ are better if you are going to be doing something related to data science and it requires fine-tuning or enhancing your graphics processing unit, GPU. Is that clear? That's when you can go for C and C++. If it is something in short, direct to the computer, usually we call that method programming. That you are programming very close to the computer. So you are coming up with like a driver, and that driver is for graphics. You won't be able to use what? Python. You will now use what? C and C++. Because the operating systems that we're even working with are developed using what? C. So that means it will be easy to write out what? To write out those drivers that sit directly on our machines. Lastly, we have Python. Guys, you learn Python. That's clear? Of course, you're going to also make your own informed decision, but learn Python. Why? Python is easy to learn. So when you are busy saying, I can do a tuple, I can do a list, you have not done anything. Because Python is easy to learn. So if you are programming in Python, you need to apply it to be proud that you are programming. If you have not applied it, You are just doing that just for purposes of passing that you are past programming. Because it is easy to learn. That's the truth. Someone can learn Python in a week. In a week you can finish Python. In a week you can finish Python. Just in only 1 week. And if you are sharp, you sit on a computer for 2 hours. You be a Python programmer. Why? Look at this traditional program that you can write. Print hello world. How many lines do you need in Python? 1 line. Cross to Java and see how many lines you're going to write. Cross to C and see how many lines you write. Or C++. You'll appreciate the beauty of what? Of Python. It's something you can learn in a week. So me, I advise or recommend, learn Python. Why do you need to learn Python? Of course, it is open source. You won't buy it. I've not heard of a language that you can buy and do. The other thing, it's also going to be cross-platform. Doesn't limit you. The next thing why you also need to learn Python, it can be applied in a number of what? Fields. Data science, web application development, anywhere you can think of. Even this mental programming I was talking about, Python can be applied there. But it is not as effective as what? C or C++. That's clear? Yes. So, because we have different kinds of versions for what? For Python. We have C Python, we have PyPy. You have heard about those terms? Or you have not? And then you are claiming that you are programmers. Is that clear? So we have C Python. Python which is implemented in C. That's the Python which you use. You have never given a thought about other Python. The Python which you work with is the C Python. Python developed in what? In C. But we also have Python developed in Python, which we call PyPy. Is that clear? You can move on. I won't complicate life for you. But I'm trying to tell you that when I was also like you, I felt I knew how to program. But not until I finished my studies. And I couldn't implement it. Is that clear? So that's when I realized it's hard time now to start learning strategically. You learn a language and you make sure, before you say, I've completed this language, I have implemented what? Projects in it. Where are the generations that you are going to as you finish? They are going to demand your GitHub account. That's the truth. Or people want to program. They will ask you, you say you can implement? Yes. Can you develop web applications? Yes. Share me your GitHub account and look at what you have done. You don't have. Meaning you are not a programmer. Because you need to have a GitHub account where there are some things that you have opened to the public that they can see. Projects that you work on, but for what? Study purposes. So, it's early. Right now you have time. So you can think left and right. And then you start implementing, then you have a GitHub account that you're going to be proud of as a programmer. So we can move on. So that's it basically on Python. I don't work for Python, but to me Python is better than everything you see there, as far as the languages are concerned. Because even Python was limited that we could not use Python in mobile application development. Give a game on code. How many have heard about Give? Okay, Give. If I'm pronouncing it wrong. How many have heard about that? We have a long way to go. Let's go to libraries. So the libraries you need NumPy, Pandas, Matplotlib. Start with those three. There are so many libraries. If you know what a library, if you don't know what a library is, it's okay, there is no harm. But this is usually a pre-compiled code for machine learning. Is that clear? So we have NumPy, we have Pandas, we have Matplotlib. We use NumPy when we are doing what? Math. Anything that involves matrices, use NumPy. Then for purposes of fetching your data, the other data set I was talking about, splitting it, you use what? Pandas. Then lastly, we have Matplotlib, which we use for visualization purposes. Then when you are advanced, you will find Matplotlib limits you. So you have to think about another library called Seaborn. Is that clear? So usually I encourage people learn seaborn over matplotlib, but still seaborn will require what? Matplotlib. Because seaborn is built on top of what? Matplotlib. Questions there on the infrastructure, that's what you need if you are preparing for machine learning. Go to your computer and make sure you have downloaded, installed Anaconda. If you are someone who is always online, then you can think about what? Google Earth. Then for libraries, if you go for online version, you don't need to install what? Libraries. The likes of NumPy, Pandas, and Matplotlib, they will already be there. If you also opt for Anaconda, you won't install NumPy, Pandas, and Matplotlib. They are already there. But if you go for a spider web, or you are going for Jupyter Notebook, those libraries are not there because you have downloaded it as an application. So you must make sure that you enrich it with what? NumPy, Pandas, and then Matplotlib. Then, of course, after mastering those three, you also need scikit-learn. Every statistical technique that I was talking about, linear regression, all those, they come from what? Scikit-learn. That's why you find them. So you have to make sure that you understand how to work with what? Scikit-learn. That's where you find those what? Statistical techniques. So we can move on. So for the algorithms, random forest, there are so many. Now, I'm going to give you the strategy you can use to master these statistical techniques. Right? Make sure that you don't concentrate on their math side, because they have two sides of the coin. They have the math, and they also have the theoretical part of how the what? The statistical technique works. Go for how the statistical technique works. Is that clear? They will guide you and say, if it is random forest, this is how it works. And then you concentrate on how it works. But if you are interested, later on you will advance. That's when you want to go deep into the math and see. So if you are into the math and you want to know how it works, that's why you're going to get your pen, you calculate. Is that clear? Then you go to the what? The machine. We usually do that for purposes of what? Enhancing the machine learning algorithms. But now for a beginner like you, please concentrate on how the what? The algorithm works. Leave the math bit. You will understand math as time goes on. If there is a question you can ask, there are so many, I've just listed a few of them here. Now, math and statistics, what I was called to talk about. When I was learning machine learning, it gave me a hard time to know when do I need to understand math and why do I need to understand what? Math. So here I'm going to talk from the what? From my personal experience. One, how important is math? Is that clear? Because there is when you're going to be just a user. You've been working with just GPT. There is the llama. There are so many. Is that clear? You don't need to know math. Even this project that we are talking about, there are some even models which are existing that you can get without going into what? Implementing a model. You just get the model, you apply it. Meaning you don't do anything like what? Training. You don't need math. Is that clear? But if you want to look at an algorithm, like logistic regression, you have your data set, but you want to make sure this data set is going to, usually we call it correlation. You want it to correlate with your what? Data with the algorithm. There are some things you're going to influence your algorithm. That means there are some things you're going to change in the algorithm. Parameters. Is that clear? Then there you need math, because you are now tampering with an existing algorithm. To make sure you can find unique based on your what? If you want to think about a new AI technique, like you want to get logistic regression and add it with linear regression, you need math. Because already you are bringing two components what? Together. That's what I did on my master. So to do denoising architecture and get the result, I need to make sure I bring two techniques. The power of two techniques then can work greater. Is that clear? So the same. So if you are thinking about that, you have to make sure that you are good at what? Math. You can understand the math of the what? Of the algorithm. Now, who does the math? Of course, if you are a researcher or a manufacturer. But if you are aiming for a final year project, only understand the idea, the intuition behind what? The algorithm like logistic regression. When you stand here and say, I used logistic regression because of this. That's your fact. But you're not going deep into the math. At least you know, but you are not going to do what? Computations. So that's it. Now, if you are just a user or implementer, you don't need math. I hope that marks the end of my presentation. Because those are some of the references that you can look at that I use to compare this work because it's not coming from heaven. I also hope that clear. I organized it in such a way that I can talk to you. That's the only thing that I had to do there. So you can look at machine learning for absolute beginners. You can start from there, reading through, you understand so many concepts. Then for purposes of probability and statistics, that's it. And then we also have what? Practical statistics for data scientists, where you learn about exploration. There is so much in those textbooks. So you can ask questions, that's the last thing. You can ask questions. I will be happy to respond to all the questions you have. Yes.
Now I have a question as well about the platform. We talked about that before. So I would like to know, like, how is Anaconda different from PyCharm?
How is Anaconda different from PyCharm? Remember, we're talking about something called integrated development environment. Is that clear? Anaconda is similar to PyCharm because both of them are what? Integrated development environments. But with Anaconda, you have plenty of text editors. Even PyCharm, you'll find it in Anaconda. Is that clear? So usually I tend to think about Anaconda as a data scientist platform with all plenty of editors you can think about. Is that clear? So when you install Anaconda, you're going to find there PyCharm, Spider. There are some things I even find there I don't know about. I think it is just a collection. Usually we call, you know about a suite, Microsoft Suite, a collection of application programs, Excel one. So that means I can say Anaconda is like a suite. There are so many application programs there, but application programs used in what? Data science. Any other question? Any other question that we have? I'd like to see the references. References, they are here, but I also share these slides. So I think I will share the slides, yes? Regression, I said you are predicting a continuous what? Value. That means, so if it's continuous value, that means the value is value. It's not constant. Because there are, when you train a model and you are predicting whether this is a cat, this is a dog. That's clear. But now when you are predicting continuous value, meaning they can keep on what? Changing. Now, what independent are going to be your inputs? The output is going to be what? Dependent. That's clear. So if it is the price of a house, I want to predict the price of the house. Factors that influence the price of the house are independent variables. Then the price will be what? Dependent. Any other question?
I've been asking, okay, myself this question, like, I can use PyCharm, and I write the Python code that for that. So, okay, for example, let's say maybe, what I think I might do like an example. For example, maybe I want to program a phone to do this, yeah? But I'm going to use PyCharm. I would like to know, like, how are those codes transferred from PyCharm to the machine I'm trying to maybe to automate? I don't know that my question has been.
So you're writing your code in PyCharm?
Yes.
How are they?
Then IB.
Okay.
Yes.
How are they translated?
Yes, how are they translated into that which I want to automate? Are there equipments I use? Is there a way the available is coming? Something like that.
Okay, fine. That's a very easy question. That's basic programming. You have heard about machine learning? Yes? You have heard about high level language. So a text editor is simply giving you where to write. But that text editor, like Python, it's an integrated development environment. Meaning, it has the compiler and the debugger in it. The compiler is the one that does the translation to the target language that the computer can understand, which is the form of zeros and what? Ones. So what you are writing, if the language is compiled, it's compiled. If the language is interpreted, there is an interpreter. So if it is Python, Python is interpreted. Meaning what you write is interpreted into zeros and ones. That's simple. Any other question? Yes. Yes, you can run Python without Django. Django is a web application framework. We use it for purposes of developing what? Web applications. But that framework uses what? Python. Any other question? Yes.
When you're using this anaconda, you're putting the codes like you put in the picnic or the subscriptions, or what you put there.
What you put there are a series of instructions. Is that clear? What you put there is code. What you put there is code. What you want to get, what you want to do is what you are going to what you want to do. Now you simply come up with a context. We are quite okay. But now the future will be, if you want, if it is an anaconda, you are simply going to be working correctly. If you are choosing art, there is other student. Is that clear? So anaconda for Python. Any other question? So we are putting there Python codes. Yes. So to simplify, maybe if I have not explained this very much, if you got a concept about the learning process of machine learning, the same way how I wrote them, that's how you're going to write your code. Your code will start by collecting data for what? The platform. Is that clear? Meaning, after when you have imported data, usually the first thing you do, you import libraries that you're going to use. Is that clear? After importing libraries, you now import the data. After importing data, do data cleaning. Are you going to comment your data? Are there missing data, missing values that you want to remove? Then from there, like that, follow the machine learning process. Yes? That's it. Eh? So don't be scared about what to write. What to write is clear. Go to the machine learning process. Let me just go to it again. This one here, you don't need to labor to know what to write. You have disconnected. So I will share the slides, but follow that machine learning process and look at what you're doing at every what stage. Any other question that we have? Yeah. Yes.
Yes, thank you for the presentation. But mine is not about the presentation stuff. I would like to know how did you grow your passion for these things?
Yeah, I have passion for computing. I am not a programmer. I'm not easy to say data science, anything about computing. I want to learn it. Is that clear? So the same element. It is very early for you to say, I have given up from programming. It's too early for that. Is that clear? Learn whatever sort of thing that you can come up with. And embrace what? Challenges and problems in what? In computing. If you ask, let's say someone asks you, how can you now do a snapshot here? That's clear. You go and find out. Embrace learning each and everything that requires what? Computing. That's how you have passion for what? Even actually, to learn to program is almost to learn everything. If someone is a programmer, you're going to find a no match more than you who chose to say, I've given up on what? On programming. Because to me, I feel actually programming is mind blowing. That's what I feel like. So I encourage you, become a programmer. And you can start as early as now. It's easy. Find a programming language that you feel you can work with. That way, if you have chosen Python, start with that. Even choosing HTML matters. Because some of you who write HTML think are programmers. It's not a programming language. It's not a programming language. Programming languages are there. Then we have seen Python, we have seen C, we have seen C++. HTML is not a programming language. It's a markup language. Is that clear? Markup. They're just coming up with the structure of the what? Of a web page. Any other question that we have?
Yeah.
Yes, please.
My question is, because you are talking of data sets which are on the KabAI, but now if I have unstructured information where I have to make my own data set, how do I come?
Remember what I said? Beginner, start with what? Structure. But if you feel you're not a beginner, how many have heard about Apache, Hadoop, Apache, Spark? How many have heard about Hadoop and Spark? How many? How many have heard about SQL and no SQL? How many have heard about SQL and no SQL? What's the difference between SQL and no SQL? So we have heard about SQL, that one I'm sure, but we have not heard about no SQL. So if you're interested in understanding how you treat images and the rest, go and read about non-relational data. Yes, you understand. That's what we call no SQL. But guys, it is technology is interesting. If you follow it up, it is interesting. And when you are following it up, don't follow what WhatsApp has brought on board. No, you look at how can I create my own WhatsApp. You will follow. But when you just, WhatsApp has come up with better AI, and you are busy sharing with your friends, I've written this and then he's saying this. These are some of the things that are very basic for you to implement. And even you give your own model, and the model will give you what? Output. When some people usually make fun of it, look at what it is writing. Please appreciate someone's what? Code base. Because even when it is doing that, with time, it learns. If you wrote a word in Uganda or in Yashara, it didn't understand you. It will apologize and you will feel like it shouldn't apologize. When it gives you a wrong output, you are very free to start to do what? Learn. So, this is how I want you to work with these what? Large language models. ChatGPT. We also have Gemini. What else do we have? Because there are so many. By the way, Gemini is not a new large language model. How many of you heard about Google Bard? Yes. So, actually, Google Bard was there before ChatGPT. It used to be called what? Google Bard. This Gemini that you are seeing right now. Now, here is how you are going to use it. As someone who is doing computing, don't get a question and give it. Is that clear? First do the question and mark yourself. How were you learning when you have a marking guide and a question? You will first attempt, then you go to the marking guide. Is that clear? And now some of you assignments, you just give it. Then you figure out, you're forgetting, you are training ChatGPT, but so you're not learning. ChatGPT is busy learning. Out of all the prompts we give you on a daily basis, it learns. How about you? You are just a consumer. So I usually encourage, if it is, let's say now we are even privileged, that when you access someone's PowerPoint, you can just give what? Gemini or ChatGPT to generate for you what? Possible questions to ask. Sister, how do you fail in this generation of questions? I want to listen from you. How do you fail? And then you get a debate one. Because before, we would have presentation, but we don't know what they are going to ask. Nowadays, the lecturer will come and say, the scope is here up to there. You really have the slide. Give them. And then you get questions. They are the same questions you find there in what? In the exam. Because they are learned from where? From the what? From the notes. So that's not to make fun. Any other question that we have? We are out of questions? Okay. So I come from vendors of technology, right? If you finish your studies and you feel you want to learn how to program or you want to become a machine learning engineer, we have what? We have opportunities for you. We can train you. The training is physical and online. Meaning wherever you are, you can still do what? Learn. So those who are interested, you have my contact. Yes? So you can have my contact, and for us we are a coding revolution. So the coding revolution means we are trying to simplify how to code. So either you can look at a perspective of joining us if you call yourself a programmer, but you shall challenge your course. Or you come and learn and stay with us because we are forming a family. That's not a family that stick together where we have programmers. Because now it is hard to get programmers, right? Because you don't know where they are. So we are forming that umbrella, a family. And these days are good at PHP, good at Java. That's what we are forming. If people want solutions, we provide. Because already we know this guy is good at Python, this guy is good at what. And of course we want to have that also what? Those GitHub accounts. Yes, please. Sharon is really like I don't know which Sharon. So that is basically right. So if you're interested in learning complete, you can enroll. How to enroll? You will have my contact, right? My WhatsApp contact, we can actually share a lot of including tips, coding tips on a weekly basis. We give you coding tips. How you are supposed to do what? Code easily. So you can always find them on my WhatsApp status. You can learn from there for free. But there are tips. I don't train you how to do what code. I only show you tips on coding, but I don't train you how to code. Any other question that we do have? Then
there is a question here from our YouTube. Someone is asking, could it be that machine learning is replacing or it is giving them more platforms? How best can programmers survive in this machine and deep learning era? That is the Bratek. I don't get his name very well, but he's on YouTube.
You also based influence. Usually call them YouTube influencers. Programming is not going anywhere. Trust me, it's not going anywhere. Like I've said, even when we're doing machine learning, right? Those machine learning models, they require our programming what? Skills. So that means when we stop programming, they have also what? Died off. Their lifetime has come to an end. Is that clear? So programming is like oxygen. It's not going anywhere. They shouldn't lie. It's not going anywhere. Instead, that's my perspective because I've also heard about that. You giving questions to ChatGPT, there is when it requires your touch. If the touch is not there, someone can easily say, this guy has been talking using AI. Is that clear? So it's very much possible that you come here and talk to people who say, this guy has been programming. He has been programming stuff. You can even see as crowd stuff. You can easily tell that. That's the same story with what? It's just GPT. As much as they can program for us, but we prompt them, even what they are giving you is what you have to write some time back. Meaning, it doesn't do something called real-time learning. If you brought a machine here, it will teach. Is that clear? But when you fire it with questions that are most recent, it will tell you, no, me, I'm of this generation. I will not talk about that. You get? Meaning, programming is not going anywhere. I stand still and firm to say that. Any other question that we have? Yes, please. You work with PHP? PHP is a scripting language. Scripting language. Usually all interpreted languages, we call them scripting languages. Perl. How many have heard about Perl? PHP, those are scripting languages. Even Python includes it. Actually, we call it a programming language, but it is scripting. Scripting means you can write something, run later. Is that clear? So PHP is a scripting language. That's clear. And usually we use it for back-end development. That's why you use PHP. If you're interested in coming up with, let's say, web application projects, and then you want to work on the back end, the business logic in the back end, that's when you use what? PHP. Actually, Python, someone asked about Django, right? So PHP also has frameworks for web application development. PHP, Cake, and the rest. And Laravel. Any other question that we do have?
Okay. Yes, let me ask one question on behalf of everyone. They are feared to ask it. So, how best can one balance their studies and developing their skills? Because most of these people, I interact with them, but most of them claim there is coursework, they are not doing Python because of coursework. So, how best can they balance their studies with developing their skills?
Okay. Thank you so much for the question. Now, how best you can develop a skill and also study and not get replaced. You have to have sleepless nights, my friend. If you sleep from 10 p.m. and wake up 6 a.m., you will not become a programmer. You will not. When you use the program, right? So the thing is like this. The schedule is busy. After the lecture, grab about like 1 or 2 hours, right? Immediately after the lecture, go and read what you have been told. Put it off. Is that clear? Go to sleep. What the real world requires from you is skill. Then your passion will be the what? The academic transfer. That's it. So it's a trade-off. As you are testing first class, the real world doesn't need first class. Why the skill? But here you need what? First class. That's what I used to do. And I did fail. I performed well. I had 3.85 on bachelor's. I had 4.22 on master's. Meaning, I looked at the strategy of skill development. I concentrated on it on master's. Is that clear? And I realized, even what they teach in class is the foundational if I have a skill. If I have a skill, I can fill the gaps of what? Foundation. Had I learned that, I would have first class in my bachelor's. But because I was doing the programming, you cannot get that. We didn't do anything like what HTML is CSS. And I learned how to develop what? Websites. So what I'm trying to mean is, concentrate on your skill. What do you want to become? Ask yourself that. The world is going to throw, of course, so many things on you. Is that clear? But if you are like, no, I want to develop websites, you develop them. Even when you are a supermarket attendant, you develop websites. And you earn money. That's clear. So let that skill feed you. Not let knowledge feed you. Not the salary. The salary, of course, you will be lucky if you are employed and you have the salary. Is that clear? But you can start earning from your skill. Right away, you write your pen or you put your pen down in the last one. You can start attracting what? What to work on projects. So, and that's what I want. As you're thinking about your final year project, look at where you are heading, those who are in that year. After you finish here, what are you ready to work on? That's clear. What are you ready to work on? If you are stuck and you are good, at least give me a phone call. Me, I will give you this. If you are stuck and you're like, I can implement websites, or I can implement design, I will give you this. But if you are good, how do I determine that you are good? At least do better than me. Or me close to me. Yes, because if you do graphics design and you are close to me, how give you this? Because they come every day. So giving you one. And then also, of course, if I you want, if again, I want to give you the full share. But you don't know. So that means I'm still working. You're not replacing me because I'm still working. Only what I'm trying to do, what I'm trying to say, let's make sense. Try to be excellent at whatever you do. When you choose programming, be excellent at it. Don't be a mediocre. Be good at what you're doing. That way, and people can easily notice that this guy is good at programming. You cannot be it. That's what I'm trying to mean. You see, computing is funny. There is when you claim to be good when you are even bad loss. Yes.
Some history, they told us about what this is compounded. Image minimizing when the image is contaminated. So I wanted to ask how the data science handle missing data, because I'm somehow sure that Windows had some missing data. There was some information which was not which was not revealed. Then it had calculated from this website, so that we can research about and maybe use another research. So I wanted to ask how the data science handle missing data.
Okay. There are a number of techniques that you can use to handle missing data. Usually we say imputing the data. Is that clear? So you can start from me that you have been playing with. It's powerful enough. And sometimes you can use me to have missing data. Is that clear? Then sometimes you can just let it go. When the data doesn't make sense, let it go. Is that clear? So usually we use me. Then we also use, we can also think about the needs. And there are also other strategies that I'm sure me can also see. Mean absolute value if you have heard about that. You can read about it. You can also use it for purposes of what? Having the missing data populated in your data set. Now, we are going to finish. But as we finish, of course I came with some goodies that I'm going to give you. So let's get started. Let's be ready. Those ones who want to participate. So I'm going to give to only three people, depending on how you're going to perform. So we are going to have a quiz and then we shall start. So let's be ready, then I will fire you questions. But if you are not ready, if you are ready, let's get ready in 1 minute. Of course, you're going to need to first open your web browser and then you will have your what? Sign into your Google account. Just sign into your Google account. That's enough. Open the web browser, sign into your Google account, and get started. Let's do that first. That's the last thing we are doing. Okay? The questions are very easy because they are live from the presentation. So they should be very easy. You want to do something new that you have not heard of. You are there? So I'm just going to give you the code and then you will start. I think I can display it here. Yeah. Yes, that will be easier. So maybe as before we start, did you know you can use code to generate slides? Yes or no? Let's move on to the quiz. Let's move on to the quiz.
Instructor based.
It's going to be now.
Let's join. Because I hope it will work. Let's join. Please do join. You just need to search for that quiz. And so you can use that actually. Or you can scan those ones who can.
You just you go to your browser, click write join my quiz, then you enter that code.
Okay.
Go to your browser, then you type for join my quiz.
Let's do that very fast. Then the other thing, you can also guide them, you can continue to guide them. What else do they do? Because there is where you are going to, I think, reclaim something. Don't reclaim. Reclaim, you lose it.
Can you go back?
Where you are stuck, please ask. Just losing it out. Where you are stuck, you ask. Yes. Then quiz. Then it will ask you for the quiz code somewhere. So the code is 1, 2, 3. We are there? Those who have personal internet, use your own personal internet. Because here you are fighting for something to go in. So you have to have your own. Let's do it fast. So I have 3 participants. So if you don't see your name there, that means you are not successful yet. I have Godi, I have Kulax Designs, I have Yamkama Morris. Those are now 5, 6. Let's do it fast. Those who have finished, guide others. Those who have finished, you can guide others. If you are not ready, leave. But if you are ready, try. You never know. So those are 8.
Yeah, continue.
So far now I have 9. Let's do it fast. 10. So far we have 11. 13. Anyone else who has not joined and would wish to join? Can we do that fast? Those who are joining, let's do it fast.
amount of money. Oh, you don't know yourself. Are we done? Is everyone set? If everyone is set, I will start. Answer. But the fastest person to get the answer knocks off points. So you have to make sure you read first, you answer. That's how it works. So I don't want people who will complain. So if your internet is not stable, you lose it. Okay, let's start here. Okay, we are going to go. We are going to go. So I'm just going to click on start. So I hope everyone is there. So let's go. Should now be active on your screen. So what you read, you get what's right. You click on what's right. Let's do that very fast.
Maurice is number one.
Now, two people here who are contesting very Kabuye Wamara. Who is Kabuye Wamara? Just there is no worse of family.
The target is to make sure that
if Karanzi wins here, should we assume he will win even on Saturday? He has been proposed. Karanzi is back. Kabuye, Karanzi, Kabuye. Ladies, where are you? Do you have ladies in this quiz? Ladies, Dory, and your friend. Looks like Kabuye Wamara will take this course. As if it is those who make the podium, the staff is already here.
if you are no longer seeing questions, that means you are out of the video.
I'm seeing a few new faces. I'm seeing Gilbert is coming in, Waswa. Karanzi is trying to run. Sir, I'm not saying you here.
I'm still number 10. Why?
The President Kosaku on the podium, I'm not seeing you. I haven't seen you.
Why is he not there?
Vice President in the box.
I knew you.
I know you, but what's what?
So I'll be ending the quiz in 5 minutes. 5 minutes from now, I'm ending it. Eh?
Are you okay, but are you done or you are still fighting? Oh, yeah. Where are others?
Yeah, I've got all the 15 correct, but I'm not inside the why.
The time you take to answer matters.
The system is
So we are ending 5 minutes from now, eh? So make sure you answer in 5 minutes from now.
There was a good, take a good day. We are number 5, which man. How about good? Even with 15.
So if you are still working, please. Around the world.
Bantu kan aja bukan itu.
So this, I also felt I should share this. I was talking about how you can challenge yourself. If you have made it, like if you are good at web application programming, of course, you can assess yourself. The assessment, of course, sometimes you can go websites, but then you don't put the enough. So what are you supposed to do as far as web application development and the rest are concerned? Like if there are people interested in AI and data scientists, and you feel you want to know the roadmap, how do you become one? You are going to go to this URL. It's called roadmap.sh. Roadmap.sh. So, regardless of what you want to become, you want to become a front-end, back-end, or because things start with and back-end. That means you develop a website from scratch to finish for both the front end and also the back end. So you can assess yourself. How much do you know? If let's say I went to AI and data science, they will give you a complete roadmap that makes an AI or data scientist. So these are things you have to know. Is that clear? So they are showing you things you have to know as a data scientist. So they will take you through. And ideally you will see that you don't know anything or you know something. So you can even check yourself here. How far have you gone? Is that clear? So you can check yourself from there. If you have written HTML and you feel for you can go website, it's not enough. Go there and check for front end and what you need to be known. Easy assess yourself. I need to learn this because I don't know this. I don't know the other. Then you get it. Like here you can see you need to be knowing deep learning, machine learning. They even go to specifics and recommend some books that you can use. So that's the beauty of this roadmap.
He's not here.
If you have finished Python, you are ready to start machine learning, because it is a language that is required. That's here. So you are ready to start.
That's what you're showing us. Might make that. Look me some that Python. So what do I just to myself? You know, I'm gonna create my website, and I'm not even consulting with other people. They tell me, say, if you're creating my website, I publish it there. And they told me that on your website you are at this level.
There are verification checks. You can verify your website. They are there. Like you get your code of the website, you upload. I've forgotten the name, but if you search about verification of websites, you can put there your code. Then they will show you things are missing in your code. That's the beauty with Django. When we are using Django web application development, you implement and even write cases. So when you implement, you also write your own personal cases for evaluation. That's the beauty with Django. Gives you that option of writing your own cases. And guys, to be good at all this, just surround yourself with technology. Someone was asking, how do you become a data scientist? How do you become a programmer? Surround yourself with technology. You'll get there. Okay, just surround yourself with technology. You'll get there. But if you don't surround yourself with technology, you'll be far from getting to your career. So that will be also productive because it can guide you as you learn. Because as you learn, sometimes you don't have someone to guide you that learn this, after learn this. But these roadmaps, they can help you to know what to learn. And they also suggest, right, that start with math, go to statistics, but you can even break this out. Python like that, and then you go back and see what you're supposed to do, what to learn. We're talking about cable. You can even see time series, learn what. There's so much that you have to learn. And of course, I know some people, because some people take long to have field. Is that clear? Me, I'm sure if you come to Rendershop, we shall bring you up. Is that clear? Not for advertisement purposes. I have a friend who is not from KabAI. You can start for recognition. You can start now. I have people I've sent to you as well. You can speak for on my behalf. He knows. I've touched on people who have become lecturers. I've touched on people who have gone to do programming with URI. That's clear. So if I'm lying, you can start and give them the names. It's okay.
I started done IT with him, and I'm still with him. And I know as years go on, I will be better even to how I am now. So, as he has told you, when you come to Airsoft, anything concerning technology, really you will keep on growing every day because he has tips, he's a good mentor, he teaches anything you want, you ask him. He really can give you his time and give you what you need.
Can you give them the names of the post you are in and people who are lecturing?
So like many people have passed through his hands. Yeah, he has, of course he has, as you see, he might not be very far, but he's a very big man. He has very many collections. Guys who can do graphics. If you are his close friend, then every day you'll be earning money. Even you who have like some other projects, just be close to him. Yeah, he has many connections, and of which he can't even go there to work, but he can connect you. Yeah, so the names of the guys who went there, there's Umaru, and there's Blake, and the others who we are sent to many places. They are mostly in Western. Now, since we got a chance, he came to KabAI. As you see, that's really a benefit to him.
Okay, that's it. That's enough. So you guys, me, I want to become an MP. That's why I'm doing basic. That's the truth.
Hey.
If you are learning from Kenya, you prepare my food. Be an MP. I want also to reach Parliament. That's my target. I work here by the way. I'm an assistant ICT officer. I knew why I came to KabAI. Exactly. So I just want to advise you. Sometimes it's not about money. Sometimes it's not about money. That's clear. Sometimes you have to have but you do that once you have got some money. Don't risk the money. I don't want to
Then the conversation is
work. But that's it idea. Sometimes it's not about money. So we have this place. Let's see who won. Leaderboard. So we can have Waswa come in front, Gilbert and Boniface. The rest of others, good luck next time. So we can have Waswa, Gilbert and Boniface. So those are guys who have made it. So the last two are taking, of course, the same gift. Like it's similar. I'll give you key holders. Then for the first one, we can give you
this
those.
one already got a key holder. So let's
Yeah, they're good.
Yes.
From where?
There is a question he answered already.
Yes.
So you can have the fourth one replacing him.
3 guys.
Yes.
Hey, how many are here?
No, he already has the key holder.
You already have it?
Yes, I gave him one.
It's okay, you can take
So
another.
Can take.
We have one is taking this.
So you can go.
So Karan, you can come.
So how many are here now? Yes.
So the first person is Waswa.
So the first person is Waswa. You can check. You can check. There is no harm. There is no harm. You can check. You can check.
Wow.
You can remove and deposit because they are asking what is it.
Hey.
Guys, don't be jealous, not for him. So the second person is taking Chipotle from Kosher Foods. That is Boniface. So Karaz Charles is going to take this from Rendersoft Technologies. He will show us what's there.
Hey.
Okay, so that's it. Thank you so much for your time. We shall meet next time.
Thank you, sir.